All right, hello. My apologies. I am having some allergies today, so my nose is plugged and I might sneeze. I apologize in advance for how difficult this might be to understand me. Um, and it's week 8, which is the halfway point through the semester, and we are getting kind of the beginnings of two important pieces of our semester. One of them is we're getting really close to doing what's called inferential statistics. So far, we've been looking at descriptive statistics for this sample of people in this data set called ad health. So, for example, this box plot is showing a distribution of how many siblings these people have. But this is a sample. And so we're going to ultimately lead towards using what we're seeing here in this sample and what information we have in this sample and getting some information about the population at large. And granted that this sample is not a random sample, and that's critical for actual uh, data analysis and actual inferential statistics. But just to get the idea of what that's like, we're going to be using this convenient sample of it's a large sample, which is good. So the other thing is we haven't really been putting our variables together yet. I know that in the when we got our research articles, we were looking for an association between our two variables and looking for somebody else doing research that's similar, where they're pairing these two variables and see if one has anything to do with the other. But we haven't really done that yet in our own research. And so this week we're just going to be beginning to see what that looks like. So again, we're working with our quantitative variables. So here are my two quantitative variables, and I've got the data management in there, and even my box plots. And so what we're going to do is we're going to take these two demographic variables that exist in the data set. One of them is about their race, and the other one is about their gender. And both of these concepts, or both of these attributes, are can be controversial in our society. For example, in the gender, they have two. They have males and females, and there is a wider range of gender identities that people are having these days. Uh, and yet, all we have is male and female. So you kind of live with what you got. So we're just going to analyze, breaking it up into male and female. And my apologies to anyone who is offended by what the data set has. If you identify in a different way, there's not much we can do about it with this data set. And maybe that can be part of your goal as a college student, is to really look for a major and a career that addresses that issue. And pardon me 1 second, I am going to blow my nose. Similarly with race, race is a construct. We are all cousins. And so, breaking folks down into these arbitrary groups um, does give you some information that you can't get another way, but it's just automatically going to be problematic and not accurate. Um, and then the only other thing is just to fit. You can look in the code book yourself for what these categories were named, and just to even having them tilted like this to fit into a place where it's not going to overlap with something, I had to abbreviate. So when you're using these variables, please feel free to make these categories what makes sense to call them for you. It's your research. It's your presentation of what's going on here. And so if you don't like the way I've abbreviated or the way I have identified these different groups, then as long as you're more or less getting the sense of what that group is about, you don't want to say, oh, instead of white, we're going to talk about all these people being, I don't know, make something up that's not white. You can't change what it is, but you can change how you talk about it, and that really does um, potentially change the message that you're giving with whatever graph you're giving. So enough about that. What we're looking for is one of your one of your quantitative variables being associated with either the race variable or the gender variable. And how I'm looking at that is I'm trying to look at, depending on what category we're in, is there any difference in this case, the sibling count? And the one thing that I notice right off the bat is that the medians are more or less the same for all of these. And I didn't look at the means. We'll be looking at means later in the semester. But the center of the sibling count for each of these different categories is basically the same. I think I forgot to say what this graph actually is doing. What it's literally doing is taking the data set and breaking it up into these categories, and then within that category is looking at the values of sibling count. And so, it's as if they threw away all these other categories and just looked at American Indian or Native Americans and did a box plot. Now, the box plot is vertically aligned rather than horizontally aligned, but it's giving the same information. The minimum number of siblings is 0, and the median is here around 2 point something, and immediately I'm noticing there are no outliers. And so this is kind of the reason that I changed the order. If I didn't have this race order in there, and I took this out and didn't say what order it would be and ran it initially, it ran it in a different order. But I wanted to highlight that this seems to be a difference amongst this category, that really they don't have huge number of siblings, at least in this subset of the population. The folks who identified as American Indian or Native American, none of them had huge number of siblings. Just looking at Black or African American and white, and then a little bit multiple races, these are the categories that had a lot, relative to the other groups, a lot of outliers, and this max of 20, and here's one that had 19, and it's not everybody that's out there. This is still skewed to the right, but these were the categories where there were some that had these really large families, as opposed to American Indian or Native American. Max was like 6. So, is this a significant difference between these two categories as far as what's going on with the sibling count? Maybe not, but there looks like there's an association. It looks like it matters what race you are, depending on how many are in your family. Similarly, over here with the asthma variable, what age were you diagnosed with asthma? And again, this is restricted to only people who've been diagnosed with asthma, and asking, well, what age were you diagnosed with asthma? And it looks pretty clear that the boys are diagnosed younger than the girls. Why is that true? What is that about? We can speculate why that would be, but this seems like there's an association between your gender and the age you're diagnosed with asthma, if you ever were diagnosed with asthma. And so that's what we're looking for. You're going to go ahead and borrow my formatting code and do what you want with the order of things, but you're going to play around and find one of your quantitative variables and then one of these demographic variables, either race or gender, that when you look at the side-by-side box plot, you see what you think might be an association. There's a little bit of a difference in your quantitative variable between the two categories, or between the many categories, if there's many. Okay. Long-winded, I apologize, and I again apologize for sneezing in the middle of the video. But hopefully this all makes sense when we go over to class. All right, take care. Bye.